So it's reached my ears that some of you are having difficulty with balancing equations and working out whether things are soluble or not. So let's help you through that with this little video of addressing a question. And here's the question. Solutions of sodium chloride and silver 1 nitrate are mixed. A white substance forms. What is it? To start working out this answer, you've got to have 3 sources of information. One of them is your sheet of polyatomic ions. Now, your sheet of polyatomic ions is available in Teams, General, Channel, Files. The folder's called Things You Use a Lot, because you'll be using it a lot. The second thing is your solubility rules. Now try and put that on any assignment that you need it for. You've probably seen it 6 or 7 times now. Here's a little excerpt that we'll use in today's problem. The last thing you need is your periodic table, because this is chemistry. And in chemistry, you always need your periodic table. And I've drawn a little simplified version down here, because here's the first 20 elements, and I've labelled the groups 1 to 8. That's because it's simple, and because I didn't have room to do all of the 108 plus atoms, elements that are on the periodic table. That's your 3 things: polyatomic ions, solubility rules, periodic table. If you got those, you can do the work. So, the rule for doing these is work out the formulae of the reactants, sodium chloride and silver nitrate. And then you work out the products, and then you work out which one of those is not soluble, because that will be your white substance that forms at the end. So let's start with sodium chloride. Sodium is Na. Here it is. I put a little ring around it earlier. Na, it's in group 1. If it's in group 1, it's got 1 valence electron. If it's got 1 valence electron, it's going to become stable in a reaction and lose that 1 valence electron. And if it loses an electron, it loses a negative. And if it loses a negative, it becomes positive. So there it is. Sodium ion, a single plus. Then we get to chloride. Well, chloride, here it is chlorine. In the periodic table, it's in group 7. Or if you look at it on one of those big periodic tables, it might be in group 7A or group 17. But we've simplified things down, so we're just calling it group 7 right now. And if it's in group 7, it's got 7 valence electrons. And if it's got 7 valence electrons, it tends to gain 1 electron in a chemical reaction in order to become stable, like argon, which is a noble gas. It doesn't do anything. It's stable, it's happy, it does nothing. But chlorine needs to gain 1 electron to be like argon. And if it gains 1 electron is negative. So a chloride ion has a single negative charge. There it is. Now, silver nitrate. Now, silver nitrate, you're not expected to know where silver nitrate is on the periodic table. You're not expected to work out the charge. So it gives you the charge in the question. It says 1. Now 1 what? Is it 1 positive or is it 1 negative? Now of course silver is a metal, right? Metal used for jewellery. And if it's a metal, the only thing it does in a chemical reaction is lose electrons. And if it loses electrons, this tells you it loses 1 electron. So it's a single plus. And then nitrate. Nitrate you won't find on the periodic table at all because it's not an element. It's made of 2 elements. It's made of nitrogen and 3 oxygen atoms. And it's got a single negative charge. How do I know? Because I just have to look it up on the polyatomic ions sheet. You are not expected to know the polyatomic ions. You're expected to know how to look them up in a resource or a reference. And so, NO3 minus is the nitrate ion. And so we have our 2 reactants, Na plus, Cl minus. The charges balance, they cancel out. We've got no need for any twos or subscripts or anything. Ag single plus, NO3 single minus. No need for balancing of that. We've got our reactants. Excuse me. Thank you. So let's have a look at the products. To get the products of a chemical reaction like this, which is a double displacement reaction, what we do is we take the positive of one reactant and we place it with the negative of the other reactant. So one product is going to be sodium nitrate. The other product, you take the other positive ion, the other negative ion, and you put those together. So it's going to be silver. What's the other one? Chloride. That's what we got. Now, what we've got to do is look at the solubility rules to work out what's soluble and what's not. And what's not is going to be the answer to our question, because it forms a white substance that is not soluble. So we see it. Now let's have a look at this one. Sodium chloride. Group 1. Sodium's in group 1. Everything in group 1 is soluble. Silver nitrate. Nitrates. All nitrates are soluble. So that's soluble as well. We can show that in a chemical reaction by putting AQ, aqueous or aqueous, just to show that it's dissolved in water, because aqua is Latin for water. So let's have a look at the products now, because obviously the white substance was a product because it was not there before we did the chemical reaction. Sodium nitrate. Oh, all nitrates are soluble. All group 1 elements, compounds thereof, are soluble. It's soluble. And the last one, is that the culprit? Is that the white substance? Is that what we're seeking? Is that the answer? Very probably, but let's check. So, silver chloride. Now, group 7, ionic compounds of group 7 elements. They're all soluble except silver chloride. There it is. Silver chloride. That's insoluble. It's a solid. So we do a state symbol to show it's solid. That's the precipitate. We can put a little arrow to show that it falls down because it's a precipitate. It comes down to the bottom. That's our white powder. It's silver chloride. We've done it.